Hey everyone, welcome to part 7 of my Roguelike and Godot for Complete Beginner series. Today, I pretty much just want to get our enemy character with HP bars above their head, take damage, and then die after they lose all of their HP. Ultimately, I kind of want it to look like this, where there's just a small red bar under each character in the game, just keeping it looking very simple. And as you lose health, there'll just be a black bar there left. But before we can have an HP bar, our swordsman character actually needs to have some HP, so let's go ahead and give him some. Because this is a roguelike, the strength of our enemies is going to scale either over time or through more levels or however you want to design your game. So usually you're going to have some amount of base HP, and then when you spawn them in, you'll scale it up. So we're just going to start with a base HP and work with that for now. So go ahead and just add a bar base HP, and I'm just going to go ahead and set it to 3 for now. And then I'm going to go ahead and create a max HP, which is going to be the most health that they can possibly have. And I'm just going to set that to an int. And then for HP, you also need to know their current health, so that way you can track when they start losing health and eventually reach 0. I'm going to create a function in here called setStats. And what this is going to eventually do for us is handle all of our HP setting, damage setting, all of those calculations based on whatever factor it is, which in our game, I'm going to do what level number we're on. So maybe it'll be like base HP times level number. So on level 1, it'll be 3. Level 2, it'll be 6, whatever. And the same will apply to the amount of attack they're dealing, maybe how fast they're going, etc. So when they get spawned in, we're just going to use the set stats function, and it's going to take care of all of that for us. So I'm going to go ahead and set our max HP to equal base HP times, and then I'm going to say level number. And why don't we go ahead and accept an argument in our setStats function for our level number. So this function will get called by our level script when it spawns in the swordsman, and it will pass to the swordsman what level it's on, and then each individual unit that gets spawned in can decide for itself what that means for its own HP, attack, defense, etc. So we know that level number is always going to be an int, so we're going to go ahead and define that. And then when it spawns in, it's always going to have its most health. So if its max HP is 3, then its current HP is going to be whatever the max is. Now, for simplicity, since we're not actually dealing with spawning in swordsman yet, I'm just going to go ahead and call our set stats in the swordsman function. And I'm going to say that we're on level 1. And I'm going to leave us a note, which you can do by using the pound sign. And any text that you write after the pound sign is just something for you to know. I probably should have talked about this earlier, but it's normally very good practice to label anything with these notes that is not immediately clear when you're just reading your code. So I'm just going to go ahead and leave us a note here that's going to say, this will be called in our main level function, but it's here for a test. Okay, so now when our swordsman enters the scene, and since he's already in our main level 1, he's in here. So when the game loads, it's going to run our ready function, and it's going to set his HP to 3. Now, to actually give him an HP bar, we want to go ahead and add a node to our swordsman. This is going to be a progress bar. If you want to use additional textures, you can use Godot's built-in texture progress bar. But for simplicity, we're just going to use the regular progress bar. Now, I think it would look best if this health bar was right above our player. There's some pretty fancy positioning stuff that you can do with a control node, but we're going to keep it pretty basic. Our character sprite is, I don't know, maybe about 64 pixels wide. So I'm going to go ahead into our layout and transform, and I'm just going to go ahead and set our size to be 64 long, and I think it should be quite a bit thinner than this. So I'm going to set it to maybe 16 pixels tall, and you'll see that we're unable to do that. This is because we have show percentage turned on, and there's text filling our percentage bar. So our text would look weird based on our current theme and font settings and all that stuff if this got any smaller than that. So we can actually turn off show percentage, and then we'll be able to shrink this a little bit more. And I think that looks good. I'm going to go ahead and drag this to about the center above. And so if you wanted to see what this would look like, Over here in our properties, we have a max value and a min value that it can be set to. And we're going to mess with that in code because we know that our max value is probably just going to be what our character's HP is. But we can turn up or down our value, and you can actually see what it looks like as it fills up. And for me, I don't think that I love the way that this looks. So let's go ahead and toy with some of those settings. As is the case with all control nodes, which is any of these nodes that are green, they have themes and theme overrides, and this is generally what you're going to be using to control the way that your control nodes look. So if you want custom looking menu buttons, anything UI related, you're going to be changing stuff in the theme. In our theme override, we have an area called styles. This will let us change both the background and the fill color of our progress bar. And I want it to look like Vampire Survivors, where the health bar is a complete rectangle and is black, and then fills in with a red rectangle. You'll notice if you try to go in here and start changing stuff, it won't let you. It seems to be all locked out. I'm not sure the exact reason for that. I don't like to mess with control nodes too much, but you can simply get around it by adding a new style box. So we're going to choose style box flat because we just want a flat color. And so we're going to go in here, and since this is our background color, I'm going to move this down to all the way pitch black. And then for our fill color, I'm going to go ahead and do the same thing, get a new style box, and I'm going to make it that red like Vampire Survivors. I recognize that this is a really simple look, but that's all that we need for this case. Obviously, if Vampire Survivors was as successful as it was with this style, there's nothing inherently wrong with it. Now that we actually have our health bar, let's go ahead and access it in code so we can modify some of the properties of it. In our enemy script, I'm going to go ahead and create a function called update UI. And in here, we're just going to handle looking at our HP when something changes, and we're going to update our health bar accordingly to what happened. We also are going to need access to our progress bar. So let's go ahead and just add a new onReady var. I'm going to call it health bar, and we'll set it equal to our progress bar. Now, the main values that we're interested in here with UI is actually its value number. So initially when we set the stats is probably when we should set the minimum and maximum value for our health bar. And then in the update UI, we'll just change the actual value and make sure that the progress bar reflects what that value is. So in our set stats, let's go ahead and go to health bar, and we're going to say .max value because that's one of its properties. If you're ever curious about that, click on it. Look at our properties that we have access to here. And we're going to go ahead and set our max value to max HP. And we're going to go ahead and set our current value to current HP, which we also know is equal to max HP. Oh, health bar dot value. And its minimum value is already 0, and that's good for us because once it gets to 0, that's when they're going to die. And then in our update function, we only need to update our current value with our current HP. So I'm just going to go ahead and also copy that there. So now if we load this in, we should see our enemy load in with a full health bar. And I think the health bar looks appropriate, maybe a little bit too thick, so maybe I'll thin it out some, but that otherwise looks just right to me. So I'll go in here, I'll go back to the transform. I'm going to move this down to say 12 pixels, and I'll shuffle it down a little bit further. And I want to make sure that the health bar always renders behind the sprite. So I'm going to actually move it all the way up here to the top. So that way it'll render first, and then the sprite will render over top of that. And just so you can see, if we set our current HP to be lower than our max HP, it'll have a lower number in our progress bar. The progress bar takes care of updating itself visually. All we need to do is update the values within it. So now our enemy actually needs to take damage, which will involve putting a damage value in our arrow, and then our enemy having some way to detect incoming damage and take it. So first I'm going to go ahead to our arrow, and I'm very simply just going to add a damage var. So I'm going to say var damage, and I know that this is going to be a float because we might not always deal exactly 1 or 2 damage based on whatever weird scalings you might have in your game. Now, when our player spawns in the arrow in our attack function, we need to remember to set our damage value. So our player now needs a damage var. Much the same way as it's going to be for our enemy, our player needs to have some base values that are going to also be scalable. So we're going to go ahead and add for our player. I'm just going to create a note here, and I'm just going to say base stats. And I know that this whole list of variables that's going to come underneath is going to be all of our stats. But for now, I'm just going to add a base attack variable. You can make this a float or an int. Your base attack is probably always going to be a whole integer. And then I'm going to create a current attack value. And your current attack is going to be, you know, however you want to calculate it. We'll probably take care of that in a future video where it'll be like your base attack times the level that your player is times whatever boosts they have and all that stuff. So you'll have to do some kind of calculation when you level up or whatever to update your current attack. For now, I'm going to create a set stats function in our player, just like we did for the enemy. And we're just going to add in some dummy values just to get it up and running. So I'm going to say that our base attack is just going to start off at 1 damage. And then in our set stats, I'm just going to say our current attack is just going to equal the base attack. And then in our ready function, I'm going to call our set stats. And now our player has an attack value. So when we spawn in our arrow, we are grabbing our new arrow scene and saving it to a var. So we're able to, you know, change those variables within our arrow. So like down here, we have new arrow and we're setting its target, its position. We're going to go ahead and set our new arrow dot damage value to just be our current attack. So now our arrow carries that value and it's going to take it to our swordsman. So our swordsman now needs to be able to find that arrow and when it gets hit, actually take that damage. To do that, we're going to go ahead and add another area 2D. This can be a little bit tricky to think about on your own, how you want to handle your collisions, whether you want it to be like a physical collision or if you want it to be an area and just detect that something has entered. For the most part, the way that it will go is a hitbox, which is going to be like your sword swinging or your arrow flying, is going to be a physical body and have a collision shape. And your hurt box, which is going to be the object that's taking damage, so you'll have a hurt box around your player, your enemy. If you're doing a fighting game, you know, sometimes you decide like if someone is punching, is their fist also a hurt box? Like, can they take damage on their fist as well? If it's something that can take damage, then you're going to check and see if a body like comes around into it. I think that's going to be our best case with our swordsman. So I'm going to add an area, and just that way we can keep things straight. I'm just going to name this our hurt box, and I'm going to go ahead and add a circle collision shape to our character. And it's going to be hard to set this collision shape correctly with our player being in this weird frame. So go ahead and go to your sprite, just change your H frames to whatever texture you have in there. For me, it's going to be 4 H frames, and I can see that our character's right there. It can be really challenging. See now that we've got 3 collision shapes surrounding our character because we have his physical body that he collides with the environment and uses for path making. We have the area that he's detecting if the player is in range of him. And now we've got this hurt box. The easiest way to handle it is select the actual item that you want to deal with in here, and it will favor you clicking on that when you're messing around with it. So generally we want the hurt box to be more forgiving to the player, so we're going to make this pretty big around him, but we still want it to be pretty accurate. I think that looks pretty good to me. I'm going to turn off grid snapping, and I think I kind of want to center this a little bit more around the sprite. So what I'm going to do is I'm going to hold down Alt, and then you can left click from anywhere on the screen and drag this to be more in line with where the character is. The reason that you hold Alt, once you have something selected over here, and maybe say you wanted to try and move it, you could left click here and, oh, I'm trying to move it around, I grabbed the wrong thing. Doesn't always happen, it doesn't always behave right, but if you hold Alt, you will always grab the thing that you wanted to grab. So now that I feel like I got that how I want it, in our hurt box, remember we only want the hurt box to be looking for projectiles, so that when the arrow comes in, we know it, and then we can do whatever it is that we need to do with it. Now to actually detect that arrow, we're going to go to our hurt box, we're going to go to its signals, and we are going to look for a body entered. That's because our arrow is a body, not an area. So on body entered, and it'll automatically name it for us on hurt box body entered, and that helps us keep it a little bit straighter. Something that I really don't like when I'm working on code, this is very non sequitur. When you're working at the bottom of your file, you can't scroll down any lower. I hate looking down at the bottom of my screen. There's actually a wonderful setting for this. If you go to your editor settings, there are a ton of customizable settings that you can make to your Godot editor to make it look and feel and play the way that you want it to. For this, we can just go down to our text editor, and in our behavior, I want to turn on scroll past end of file. That'll just let you scroll down all the way so that you don't have to look at the bottom of your screen. It's wonderful. So when something actually enters our hurt box, we know already that it's going to be something with a collision type of projectile because we are only looking for projectiles. But maybe there's other kinds of projectiles in there. Maybe we'll add fireballs. So we don't want to look specifically if body is arrow. Normally when we're handling these areas, we're going to be asking questions like if it's in the group of player. And we know that we're going to do specific things if it's a player that walked in. For our arrows, you don't necessarily have to do that because our hurt box is only looking for projectiles. And in the mask, it's just set to projectiles. So nothing else will be triggering this other than things that are on the projectile layer. So we can handle this very simply. And we just have to remember that in the future, for any projectiles we make, they all need to have a damage value with them, which I don't think that that's going to be any problem. So we can just say that our current HP minus equals body. And in this case, remember that our body is actually the arrow and it has a damage property. So we're going to take damage equal to however much damage the arrow has. And then after that has happened, we need to check if we died. So if current HP is going to be less than or equal to 0, then you might have some kind of death animation that you want to play, and that's where you would do all of that here. I'm simply just going to queue free, which will get it off of our screen. Otherwise, if we didn't die, then we need to update our health bar to show that we took damage. So I'll say else health bar dot value equals current HP. And remember that that's going to automatically update for us. So now if we go in and test this out, we should have our arrows shoot. They should collide with the enemy, assuming they don't get hit on a rock. And our arrows are flying through him. We don't want that to quite happen. But he is taking the damage like we expected. And he does die on that last arrow hit. We got a weird error here after that had happened. This was because our arrow was looking for an enemy that had despawned. A good way to diagnose this is when your game crashes, it doesn't actually close, and it'll leave you with an error here. And in your debugger, you can go to the error and read specifically where it happened. So our error happened in our player attack function. And you see that it is looking for the key or property position on an object that has been removed from the game. So you can actually go to your player attack function, and it shows us what line that it happened in. And this is because we're looking for an enemy that no longer exists. What must be happening here is that in our current scene, we track all of the enemies that we currently have. But once that enemy died, we did not update that list, which led to our player still thinking there was someone to shoot. And when it tried to shoot them and there was nothing to shoot, the game crashed. So we need to now make sure that those arrows despawn after they hit somebody. And we need to update our enemy list once an enemy dies. The easiest way to get rid of our arrow is after it has collided with our friend here, we can just queue free it. But we might want something to happen where our arrow hits somebody and then it'll ricochet to somebody else, or it'll pass through, or anything like that. So maybe that simple solution will work for you, but I think we should do something a little bit more interesting. Oh, also when your game crashes, it doesn't automatically close. You can just hit this stop button and it'll close out of it for you. I think instead what we can do in our hurt box, instead of just queue freeing our arrow, we can have in all of our projectiles a function. Maybe we'll call it on hit enemy. And what this will do is call this function from our body that it collided with, which is our arrow. So now we need to go into our arrow and actually add this function in. And make sure you spell it the same. So we spelled that func on hit enemy. And then this is where we can decide what we want to do with it. Do we want it to find the next player? So on and so forth. And right now, we only want it to disappear. So I know that this seems a little bit of a silly thing to do and doesn't make a lot of sense. Like, why couldn't we just call this in the swordsman? But this gives you a little bit more flexibility with what you want to do with it. So now after the hit, the arrow will despawn, and we need to update our enemy list when an enemy dies. One really effective way to communicate between nodes is through signals. So we're going to go ahead and create our own custom signal rather than using one that's been built in like we've been doing. Like, for example, the signals that we've been working with is like this hurt box. We've been connecting, on body entered, on collision, so on and so forth. We can actually make our own signals that'll carry our chosen data and call our own functions, which is really cool. Normally, you're supposed to organize this in a way, call up, signal down. This is usually because whatever is going to be at the top is always going to be there. Like when we're on level one is always going to be there no matter what. But the many enemies underneath of it won't always be consistent. So we don't want to try to connect to each individual enemy, when instead our level can just generally broadcast information and all of our enemies can generally pick that up. Whereas our enemy will always know that level 1's going to be there, so he can always call functions that exist in level 1. But you'll run into errors if you try to have your node on top call functions from nodes on the bottom, because what's in the bottom will be changing often. I usually just use signals for everything because signals are generally much cleaner. So I'm going to create a signal called enemy died. And this is all that we need to do for it. If we want to add in specific arguments to this, you can say right here, you can just add parentheses to the end of it and throw in parameters. You can type it and say that you want your enemy to be of type, character body. We don't actually need that in our case. We just generally want to know, did an enemy die? And if that happened, then we probably need to redo get enemies. So for each enemy that we end up making, we'll need to emit this signal so that our level will know, hey, somebody just died and we should update our enemy list. So down here, instead of just immediately queuing free, we'll want to do something before that. Don't write code that you want to happen after queue free, because if you queue free and then try to run code, whatever's trying to run that code will vanish and then won't run the rest of that. So first we need access to current level that we're in, and we have a really easy way to do that with our groups. We have this main scene group. So in our enemy, we can create a variable called current scene. And if you want to type this, I'm pretty sure it's a node 2D. You could be more specific and call it a level as well, but I'm just going to leave it untyped. And then in our ready function, we are going to set current scene to get tree dot get first node in group. Oh, I don't think it likes that I have this colon here. Get first node in group and main scene. So we're only ever going to have one main scene in play at a time, and it's always going to be our level scene or maybe our menu scene or whatever, but there's never ever going to be anything other than one main scene. So we always know that this is going to grab level 1 or whatever level we're on. So then once we have the current scene in our death function, we can just say current scene dot enemy died dot emit. There's another way that you can write this too, but I like this way better. You could say current scene dot emit signal, and then in quotes here, you'll pass in the string of the name of the signal, which will be enemy died. And then with a comma here, you can put in all of the arguments that go along with it, but ours doesn't require any arguments. I'm just going to go ahead and go with this one. And so now we know that that signal is going to get emitted when the enemy dies. So now we need to actually do something once that signal's emitted. So he generally broadcasts that up, and now we need to catch it. Let's create a function. We're going to call it on enemy died, and I'm just going to call get enemies. Then in our levels ready function, we need to actually attach this signal to this function. That can be done by simply typing enemy died dot connect, and then we're going to connect it to a callable, which is a function, and that's going to be on enemy died. Sometimes it'll try to put a parentheses here and it act like you're trying to call a function from inside of this, and you don't want that. You just want the callable to look like this. And if there's any arguments coming in, I don't think that you need to list them here. Okay, well, this has turned into an interesting learning opportunity. So I thought that this would work, but if we go in here, we look at it, I have it printing our current enemy list before it gets destroyed and after, because this is getting called at the beginning in ready, and then it's getting called again when that signal emits. So we know that that signal is emitting, but this is really bizarre. What's happening is that our enemy emits that he died, and then he's queue free. When this happens, we go up to our level and we run this get enemies. He hasn't actually been deleted yet by the time this gets rerun, and so he still shows up as there in this list, even though he's dead like a millisecond later. And so the enemy list still holds that swordsman even though he's just been destroyed. So then our player tries to shoot because the enemy list still is holding the swordsman, but it's gone. So there are a couple ways that I can think about working around this. A really dumb one would be to constantly update get enemies. So this would keep this updating every single frame. Nothing would get past it, and there would never be anything in there. So it would work, but it's not smart to try and run unnecessary functions in process. So instead what we can do is we can actually add an argument to our enemy died, and we can make it so that the enemy that dies will send itself. So like if we run this again and you see we're printing the enemy list, one of the enemies that it's printed here is the actual object in our game that is that swordsman. Is swordsman character body number 3924 blah blah blah. This is what the engine is assigning to it by default. So we can send that information from our swordsman when he dies to our main level, and then we can remove this swordsman specifically from our current enemy list rather than like rechecking our enemy list. Okay, so in order to implement that, I don't want to specify by type of swordsman in case we have other enemies that die. So I'm going to say that we want an argument of character body 2D. So I'm going to say dead enemy is going to be the name of our argument, and I'm going to assign it to type character body 2D. Now, on enemy died, we need to actually take that dead enemy as an inputted argument. You could call it dead enemy as the argument that you're taking in as well, but I like to keep all the names different so that things don't get confused and you accidentally rename variables that you've already assigned and that kind of thing. So I'm just going to I'm going to take the argument here, enemy that died, and we know that that's going to be still a character body 2D. And instead of getting an enemy, we need to actually remove the enemy that died from the enemy list. I feel like removing something from an array is more complicated than it needs to be, and I don't know that if I'm overcomplicating it or if it actually is just complicated, but this is the way that I have found removing stuff from an array to work best. Other programs tend to just have functions that'll be like, take your array and then remove a specific object from it, and it'll automatically go through and find it, but I don't think that exists in Godot, so what you have to do is you find the index instead. So you take the enemy list and you use .find, and then you pass in whatever object you're looking for. If you're looking for a string, if you're looking for an integer, you'll put whatever that is. In our case, we're looking for, you know, the character body in there. And then once it finds the thing with that exact value, then it'll get us the index, which will be 0 in our case because we only have one thing in there, so it's going to be at index 0. And then we're going to use remove at, which will take something from our array and pull it out and automatically resize our array. There is something that you can just like, it's called like pop at or something, and it'll get rid of the value at that index that you found, but it doesn't actually resize your array. So then if you try and do anything else before adding a value to that spot, you'll get an error that there was nothing at that index. And I'm putting this here for debugging to actually test that what we have is going to work. So now we need our swordsman, when he emits that an enemy died, we need to actually pass something into that. And he is just going to be passing himself. So now if we test this, we'll see when he dies that we have an empty array for our enemy list, which is good. That's what we want. So it actually did remove it from there. But we had an error that an arrow was created and it didn't have anywhere to go. So now we need to stop our player from actually attacking when there's nothing to attack. So our actual attack function is being called in our animate player. And basically we're just checking if we can attack, which means like we're not on cooldown from shooting it, then do an attack. And so we don't actually want to just rip that attack. So we want to say if we can attack, and if there's something in our current scene dot enemy list. So we're going to say current scene dot enemy list, and then we use dot size to check how large it is. And so if there's anything in there, it will be more than 0. Now if we try and run it, You'll see that he dies, and we no longer try to attack. All right, I think I'm going to go ahead and call it there. We were able to add a colored health bar to our swordsman. We were able to get him an HP value and be able to detect when he's been shot. We made it so that our arrows actually carry the damage value, and that our player also has a damage value and no longer attacks if there's nothing there to hit. So thank you guys so much for watching. I really appreciate the time that you put into this. If you want to keep up with the series, please subscribe. Otherwise, YouTube is not going to show you my video. And if you want to like and comment, even if you don't have anything to say, I would appreciate it just because you're helping the algorithm promote my video to other people. Of course, if you have questions, please ask and I'll do my best to answer. Next time, we'll probably add the player's health bar and letting the player take damage, as well as an XP bar that the player will earn and fill as they kill the enemy. Thank you again, and I'll see you in the next one. Take it easy.